Welcome back to Drugs and the Brain. This is the first lecture that we will actually go into depth on our subject matter, and we are going to discuss the concept, what is a drug, by giving you examples of 4 drug molecules today. First of all, though, we want to talk about the origin of the word drug. It arose in Middle English in about the 14th century, and we've gone to a dictionary to get a good series of definitions for drugs. First, in general, it's a substance used as a medication or in the preparation of medication. About a century ago in the U.S., the Food, Drug, and Cosmetic Act systematized the definition of a drug, at least for regulation by the FDA, by the Food and Drug Administration. It's a substance recognized in an official pharmacopoeia or formulary, and you can see 2 pharmacopoeias, one for animals and one for people, at the FDA, fda.gov. According to that same act, it's a substance intended for use in the diagnosis, cure, mitigation, treatment, or prevention of disease. And also, it is a substance other than food intended to affect the structure or function of the body. So, food is not a drug, an irrelevant definition. And finally, according to the dictionary, a drug is something, and often an illegal substance, that causes addiction, habituation, or a marked change in consciousness. And this is the definition used by many people, and it is also the definition used by the U.S. National Institute on Drug Abuse, part of the NIH, which supports a lot of research, including some of my own research. In terms of trivial names for drugs and structural formulas, we're going to give as an example nicotine, and throughout this course we're going to use nicotine as an example. It figures prominently in my own research. We will also discuss lidocaine today, morphine, and also botulinum toxin. These are very different molecules, as we'll see. The first 3 of them are best described in an NIH database called PubChem, and here are the accession numbers for each of the records. So if you type PubChem 3676 into your search engine, you'll get the record for lidocaine, etc. Botulinum toxin is best described in another database, the so-called Protein Data Bank, whose files are curated by an international organization that looks at X-ray crystallographic coordinates and at nuclear magnetic resonance structures. So these are our 4 examples, and they exemplify the concepts that we are going to discuss in Drugs and the Brain. Drugs activate and block ion channels. Nicotine activates, lidocaine blocks ion channels. Drugs act on G-protein pathways, for instance, morphine. Eventually, if an organism is exposed to drugs, both nicotine and morphine activate genes, an important concept in chronic exposure to drugs. Botulinum toxin is an example of a protein drug, and this class may become more useful for neuroscience diseases eventually. Botulinum toxin is really the only example at the moment. In this session, we won't treat drugs that act on neurotransmitter transporters, but they are very important, and we will treat them later on in the course. In terms of atomic scale structures, it is perhaps useful to go to PubChem, to the record for nicotine, for instance. What do we see here? We see that the nitrogens are in blue. This is more or less standard. And to get the best possible dimensionally accurate structure, we go to the 3D conformer section, and there are actually about 8 of these conformers in PubChem. They have rotations around this single bond. They have slightly different puckering and torsions and angles on all of the bonds, and we can get a good feeling for the ways that the nicotine molecule can change its shape. We can do the same for lidocaine. Here for lidocaine we add the fact that the oxygen atom is usually portrayed in red. To get a nice structure of botulinum toxin, we would go to the protein data bank, and we will do so in subsequent lectures, but not today.